The foundational skills. Now let's talk about the intro to this packet. So what we're going to do is we are actually going to have an end game here of solving equations with all of this stuff in here. And you need to know a lot of these properties in order to move forward, and some of them you already know. For example, the reciprocal identities. You already know that the sine is the reciprocal of cosecant, just like cosecant is the reciprocal of sine. You know cosine and secant are reciprocals. You know tangent and cotangent are reciprocals of each other. So you already know this top half of this sheet of paper with all these identities. You also know this one. You know that tangent is y over x or sine over cosine. You know cotangent is the reciprocal, so it would be cosine divided by sine. Now the rest of them are new for you, so let's make sure we do pay attention to this. The Pythagorean identities, you will have to memorize these, so please get very comfortable looking at these. Another thing that I would like to point out to you, notice sine is squared, cosine is squared. In these Pythagorean identities, your angle or your values here for the trig ratios are going to be squared. Then you have some cofunction identities on the lower half of your paper. So you will notice they all have pi over 2. We will be talking about these. And down here at the bottom, you actually know these. This is way back from chapter 1, way back in August, when you first started doing your pre-cal. Just remember, what is in the parentheses is an input. What is outside of parentheses on the right-hand side of the equal sign is the output. Remember, if you put in the opposite input and you get the same output that you already had, that is considered an even function. For example, please look at cosine right here. If I put in cosine negative x, I still get the same output as if this was positive. So I know cosine of negative x equals positive x. I know that's an even function. On the flip side of that, if I put in the opposite input and I get the exact opposite output, that is odd. For example, right here for sine. If you notice, when I have an input of a negative or an opposite, I get an opposite output. That's what that negative means in front of the word sine. So let's write odd here. As you look through these, you only have 2 even identities here, and it is going to be the reciprocal for cosine, which is secant. So these are your only 2 that are even. All of the other ones have an opposite output. Look how all of the other ones have a negative in front of the output. So the rest are going to be odd. Okay, so those are your identities. You will be given a quiz over these identities on the day after the break. So make sure that you have this in front of you. Make sure you do not lose it. You will be referring to this often, many times. All right, let's turn the page and let's talk about our notes. Okay, so before we begin, why on earth do I have to look at all this craziness? This is a heavy concept in calculus. If you plan to continue to go to calculus in high school, if you plan to go to calculus in college, you are certainly going to need this. This is considered a foundational skill in a regular calculus course. Also, you are going to be using these identities through the remainder of the chapter, because in chapter 5, we are solving equations. So we are back to solving equations here. Let's go ahead and look at some foundational stuff. One common use of trigonomic identities is to use given values of trig functions to evaluate other trig functions. For example, Finding trig values with identities. Find the value of each expression used in the given information. So the given information right here is if cosecant of theta is 7/4, find sine. Well, that one's pretty easy because you know that cosecant is the reciprocal for sine. So if cosecant is 7/4, then we know the sine value is simply 4/7. Now let's look at the next one. If cotangent of x is 2/5√5 and sine is √5/3, find cosine of x. So remember for this one, and I'm going to leave out the variable while I explain the identity. Let me zoom in just a little bit. Remember, cotangent is cosine over sine. So with that identity, remember that's a quotient identity. It's right over there on the other side of your paper. We are going to input everything we are knowing given the information from this problem right here. So cotangent is 2/5√5. So I'm replacing the word cotangent with what it equals. And we are looking for cosine. So in my little identity here, I'm going to go ahead and put the variable back. So x is coming back. And remember, we know sine. Sine equals exactly √5/3. We need to solve for x. We have a fraction. We are just going to get rid of that fraction. We are going to multiply both sides by √5/3. So those are going to cancel out. Cosine of x is going to be by itself, which is exactly what we want. Let's go ahead and do the math over here. 2 times √5, we are simply just going to put those two together. 3 times 5 times √5 is going to be 15 √5. And remember, always, always, always simplify your answer. These √5s are going to cancel out, and cosine is going to equal 2/15. That is going to be the answer for that. All right, let's look at the next one. For the next one, we know secant is we know secant of x is 5/3. We need to find cosine. That's pretty simple because that's just a reciprocal. So just flip that upside down and you have the answer for cosine of x. Cosine of x is just simply going to equal 3/5. Now, if you notice, I am not just saying the word cosine. I am saying cosine of x. Over here, cosine of x. Over here, sine of theta. These little, we can treat them as variables. We have to have these in our final answer or you will not get full credit. This is just as important as having like units squared in area. So please make sure you are taking the variable down with you in your final answer. In your work, not as important, not so much, but in your final answer, you have to have the variable or the angle sign included. Let's go ahead and take a look at problem 4. So for problem 4, we know cosecant, this is beta. We know cosecant of angle beta is 25/7. We also know secant of beta is 25/4, and we need to find tangent. So in order for us to find tangent, let's start thinking about what we know about the given information. Remember, we know cosecant is the reciprocal of sine. So we know sine beta is going to equal 7/25. And just like with secant, we know secant's the reciprocal of cosine. So we know cosine of beta is going to be 24/25. Now remember, tangent's a division property. So tangent of beta is going to be sine of beta divided by cosine of beta. And remember, in a fraction, you keep, change, flip. So I am not showing a bunch of work here. I don't have a lot of space to show all that extra work, and it's not necessary. So to find tangent of beta, you are going to write sine, which is 7 over 25. You're going to multiply by the reciprocal of cosine. So it is going to be 25 over 24. So tangent of beta, the 25s are going to cancel out, you know that, so it's just 7 over 24. Don't forget to include that beta in your answer. Okay, let's look at the next one. The next one is leveling up. This one is actually going to take new information that you have not seen before. We're going to use it based on our trig identities on the previous page. All right, so we know sine of x is 1 over 6. We also know cosine of x is greater than 0. Guys, that just means it's a positive number, so we know it's not negative. We need to find cotangent, and we need to find secant. So secant would seem really easy if we knew cosine, but we do not know cosine. So what we are going to do is we are going to find an identity with both of those functions in there. So I have sine, and I'm trying to find cosine. I really want to find cosine because I'm going to flip it upside down to get secant. I also need cosine because I need to find cotangent. So let's look at the properties. Is there anything here that is going to have both of these properties or both of these trig functions together? Is there anything there that I can work with that has both sine and cosine? And right here it is. These are used often. So let's see what happens when I start playing around with this identity. It has sine and it has cosine. Please notice these values are squared. All right, so let me rewrite this on this screen so I don't have to keep going back and forth. So remember, it is sine squared x plus cosine squared x equals a regular number 1, just the number 1. So what do we know? Do we know what sine is? We do know what sine is. Sine of x is plain 1 over 6. Let's use substitution. Let's take the sine value and square it. So if I know sine of x is 1 over 6, then sine squared of x is 1 over 6 squared. I just did substitution. That's all that's going on right there. Now remember, we are looking for cosine. We don't know what cosine is. We just know it's positive. So I'm going to recopy this part of the identity. Okay, that is a regular kind of equation, almost like a quadratic because it's squared. Let's go ahead and make this portion of the equation by itself. So we are going to move this to the other side. Do not forget, this is squared, so this is 1 times 1, 6 over 6. The next line that you should be comfortable with in your work should look like this. Remember, we moved that value over. Again, a whole number with a fraction at this point should be very easy for you to compute. If you need to go back and watch the first video on having a whole number combined with a fraction, go do that now. Otherwise, you're going to go ahead and write 35 over 36. Now look, we're looking for just plain cosine. That's not cosine, that's cosine squared. So what we're going to do is we're going to take our pencil or our pen, and we are drawing a square root symbol. And remember, what do you draw when you draw a square root symbol? You should be thinking in your head plus minus, plus minus, plus minus. That is correct. You do draw that when you draw one of these. However, we're kind of off the hook for the plus minus because remember, it was given to us that cosine is positive. So cosine of x is just going to be positive root 35 over 6. We did not even answer the question. That was just a tool for us. Remember, we are needing cotangent and secant. So remember, if cosine of x is 35 over 6, we're going to flip this upside down for secant. Let's do the easy part first. Let's just flip this upside down. So cosecant of x is this. Secant of x, I'm afraid I don't have enough room. I'm going to write it over here. I'm going to continue my work right here, guys. It is going to be 6 root 35 over 35. Because remember, if there is a square root in the denominator, you must rationalize. And I'll just put that here because I'm running short on space. All right, there's secant of x. Now we've got to find cotangent. Remember, cotangent is going to be cosine divided by sine. So cotangent of x is going to be cosine. Remember, I wrote it in green right here. And what is it divided by? It's divided by sine. But remember, I don't have a lot of room. I'm already on my next problem. I don't have a lot of room to show a lot of work. So I am multiplying by the reciprocal of sine of 6 over 1. So cotangent of x is root 35. All right, so the right answer for problem 5, cotangent's right here. And secant, we found secant first. It's up here. Remember, we had to rationalize the denominator. Part 2 is on the way. Obviously, I got to rewrite this on a separate sheet of paper. So we're going to go ahead and go to the next video for number 6.